All right, so we're going to draw the structure for this compound right here. Hopefully you guys remember that whenever you see elements separated like this, so if you see like the H is separated and the C separated, it tells you what the molecule looks like. So on the left side of the molecule, you'll have 3 H's surrounding a C. So that's going to be this section right here. And then there's another carbon with 2 hydrogens. There's another one with 2 hydrogens. Another one with 2 hydrogens. And on the right side of the arrow, you're going to have a carbon with 3 hydrogens. So just based on the formula, if you see things separated like this, it'll tell you what the molecule looks like. And then as you guys know, you could draw your single bonds and just kind of connect them all together. Okay, so this is what your molecule is going to look like. Okay. So very simple. These are the types of molecules that we'll be looking at going forward. But any questions on this right here? Okay. I'll give you guys about a minute or so to copy this down because we'll be using this for our first example problem. Just make sure you guys have this on your notes somewhere. But then in a minute, we'll move on to the new stuff. All right, so today we're going to learn how to draw the last type of structure I'm going to teach you guys about. And this one is called skeletal structures. And there are a couple of rules that we need to write down because they apply to skeletal structures. So let's copy them down first. All right, so I'm going to have you guys copy these down. The first rule for skeletal structure is you're going to replace all of the carbons with corners. I know that might sound a little weird, but I'll show you guys what it looks like in a second. But you're going to replace every carbon with a corner. Just write that down. Okay, you're going to replace all the carbons with a corner. Okay, after that, you're going to ignore all of the hydrogens that are bonded to carbon. So in the example that we just did, you guys saw how there were a bunch of hydrogens connected to carbon, right? If you see a hydrogen connected to a carbon, you ignore it. You don't need to draw it. Okay, but the caveat is if there's a hydrogen connected to a different atom, you have to draw that. So you only ignore hydrogens that are bonded to a carbon. Okay, and then the last rule is you just draw all the other atoms. So if you have like a nitrogen or an oxygen or a chlorine or something like that, you draw all of those. All you do is you replace carbon with corners, and you can ignore all the hydrogens that are connected to a carbon. So those are your 3 rules. Just make sure you guys have them jotted down. Okay, because we're going to refer back to them as we do our problem. Okay, so we're going to look at the problem that we just did, and we're going to turn this big, complicated looking structure, and we're going to turn it into a skeletal structure. So we just talked about how what we're going to do is we're going to replace all the carbons with corners, okay? So if you guys look, let's count the carbons first, okay? So there's 1 carbon here, 2nd one, 3rd one, 4th one, and 5th one, okay? So we're going to be drawing these carbons and turning them into corners, and we're going to ignore all of the hydrogens because they're all connected to carbon. So I know this is a big annoying structure, but what we're going to do is we're going to turn it to skeletal, and I'll show you guys how easy it is to draw. So we're going to take this carbon right here, first carbon. I'll do it up here. That's corner number 1, corner number 2, 3, 4, 5. So this picture right here is the same thing as this structure right there. So a lot easier to draw if we draw it the skeletal way. Okay? So I'll do it one more time. There are 5 carbons. Corner 1, corner 2, corner 3, corner 4, corner 5. That's a skeletal structure. Okay, so if you want me to label them, I can. This is carbon 1, represented right here. This is carbon 2, carbon 3, carbon 4, carbon 5. Okay, so we're pretty much simplifying the way that we draw it. We're just taking all the carbons, turning them to corners, and we can ignore all of the hydrogens connected. Now, the reason why we do this is because going forward, we're going to be looking at bigger and bigger molecules. We're going to be looking at things that are a little bit more interesting, and they're very large. And so drawing it the way that we've been drawing it will take forever. And so this is just a simple way to draw it and communicate what the molecules look like. Okay. All right, let's do a couple more practice. We're going to go to this one right here. Now, you guys do not need to copy down this structure. We're going to use this as our problem, but I just want you guys to copy down the answer. Okay, so first thing we're going to do is we're going to count the carbons. Okay, so this is carbon 1, carbon 2, 3, 4, 5, 6. And if you notice, there's a bunch of hydrogens, but they are all connected to carbon, so we can ignore them. And so we're going to start with carbon 1 right here. Carbon 1, carbon 2, 3, 4, 5, and 6. And we just finished the shape because there's a final single bond. So this structure right here is drawn like this right here. It's just a hexagon. Yes?
Is it like matter how we call it?
Yeah, you want to go in the direction that this structure is shown. Yeah. Any questions? You guys think you could try one on your own? Yeah. All right, let's try another one. All right, so I want you guys to try this. So I want you guys to take this structure right here. I'll zoom in a little so it's a little bit easier to see. Sorry, it's a little blurry. But I want you guys to take this structure and turn it into a skeletal structure using the rules that we learned. Again, turn all the carbons into corners. You're going to draw all the other elements, like nitrogen, oxygen. Make sure you write those down. And you're going to ignore the hydrogens that are connected to carbon. So let's see if you guys can do this one. A little bit more complicated. All right, guys. So if you're finishing up, feel free to finish and you can check your answer. But let's start going over this. So let's start with the carbons. Okay, so I'm going to label them just so that we kind of have a reference point. I'll call this carbon 1, carbon 2, 3, 4, and 5. Okay. The way that you number it doesn't really matter. I'm just doing it this way so that we can refer back to it. Okay. So we got a carbon here. This is going to be my first carbon. There's hydrogen, so I'm going to ignore that. We go to the second carbon. So we're going to have this carbon 2. So this will be carbon 2. So carbon 1, carbon 2. Carbon 3 goes up. So we're going to go up. And then this will be carbon 3. And then it's connected to a nitrogen like this. So nitrogen. So this is carbon 1, 2, 3, and nitrogen. Okay, there's another carbon 4 here. So I'm going to draw a line going out. So carbon 4. And then if you look at carbon 4, there's an oxygen going down. So we're going to copy that down. There's oxygen on the other side of it. So oxygen. And then carbon 5 is our last corner like that. So something that looks like that. And I've labeled the carbons for you. You don't need the labels, the 1, 2, 3, 4, 5. That's just there so you could refer back to. Okay. Okay, now I do want to make one quick note as you guys finish that up. If you go the opposite direction, so if you guys take a look here, for carbon 1, we went up to go to carbon 2, right? If you went down, that's totally fine as long as the connections are the same. So if you go down instead, and then you just make this thing for the nitrogen, that's fine as well. This will be carbon 4, and then you have an oxygen going up, oxygen. So this is actually the same as this. The only difference is that it's flipped around, and it's because of the direction you go. So this will be carbon 1, carbon 2, carbon 3, 4, and 5. Okay, so exact same thing as this one. The only difference is one of them you went up, and that's why the nitrogen is on the top. This one you went down. Just make sure the connections are the same. If they're mirror images, that's totally fine. Okay. All right. Any questions on any of this? Hopefully it's not too bad. Again, just count the corners. That's probably the easiest way to do it. And as you guys do more practice problems, it'll get easier from there. Okay. All right. Let's move on. Okay, so we're going to look at more interesting molecules. So this right here is the skeletal structure for meth, or this is a structure for meth based on what we know. If you look, it's a pretty big molecule. But we're going to make it simpler by drawing the skeletal structure. So I want you guys to take a look at this and see if you guys can draw the skeletal structure for meth. Okay, one quick thing. These are double bonds. Just make sure you guys add double bonds in between the corners, and that's kind of how you do it. Okay, so take about a minute or so to try that out. Draw the skeletal structure for meth, and then we'll go over it, and then we'll move on. Okay, so I'm gonna start by just labeling the carbons. You guys don't need to do this. It's just my way of kind of keeping track of this for you. But let's say this is carbon 1, 2, 3, 4, 5, and 6. Let's start with this hexagon right here. So we got a carbon on the top. We're gonna go down to carbon 2, 3, 4, 5, 6, and then we're gonna finish the shape. Now, if you guys notice, there's some double bonds in here, so we got to draw those. So there's a double bond between carbon 1 and 6, so we're just going to add a double bond like this. There's a double bond between 2 and 3, so we're going to put a double bond between 2 and 3. And then there's a double bond between 4 and 5, so we're going to add a double bond between 4 and 5. Okay, so we can simplify this big shape right here on the right into something like that. All right, now, if you guys take a look at carbon 3 right here, this is where it kind of branches out. So from carbon 3, we're going to branch out to this next one right here. And then we make another carbon right here. This carbon right here has one that goes up. So it goes up like that. And then on the right, it connects to an N and an H. So we're going to write that. And then finally, we put our last carbon right there. Okay, so something like that should be good. Yes. Yeah, it's just the way that it's given to us. Technically, I mean, in real life, it looks like this. There's a single bond, but it didn't give you that information, so you can just write NH. Yeah, if you did the single bond, that's more accurate, but I'm not expecting that. Good question. Okay, so that's how you draw skeletal structures. And the reason why we do this is because some of the compounds that we're more interested in, like medicines and drugs, they have big structures like this. Meth is actually one of the smaller molecules, and it's already that big. And so to make it more simple to draw, that's why we use these skeletal structures. For the next thing we're going to talk about, I'll be showing you guys actually somewhat bigger molecules, and you guys will see why you want to use skeletal structures for that. Okay, but any questions on this? Yeah, on your homework or on your assignment today, you'll be drawing more skeletal structures like this, so you get some practice. Okay, but let's move on to, I guess, the last thing for today. For the last thing that I'm gonna have you guys do today is I'm gonna give you guys these big structures. I know, right? And this is skeletal. Okay, and what I want you guys to do, or I'm gonna have you guys do, is you're gonna look at this skeletal structure and you're gonna finish the formula right here. So this is testosterone. This is a hormone that your body makes. And this is what the formula looks like. But I didn't give you how many carbons there are. So what we're going to do is we're going to look at the structure of testosterone right here. And we're going to finish up the formula. So we're just going to count how many corners there are. So if you guys don't have this up on your Chromebook, I would recommend pulling this up just because it's easier for you guys to look at. But we're going to go over this together. Okay, so we're going to take a look at this structure and let's count how many corners there are. So let's start from the bottom left. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's one right here, so 11, 12, 13, 14, 15, 16, 17, 18, 19. So the chemical formula for testosterone is C1928O2. Okay, I didn't miss any, right? Yeah, I don't think so. Okay, but that's how you would determine how many carbons there are in these structures. And you can see why you want to draw these skeletal structures for these bigger molecules, because imagine drawing all the carbons, all the hydrogens for that. That would take up way too much space and be pretty complicated. Okay, but that's how you can finish up the formula using these structures. Just count the corners. Okay. All right, I'm going to have you guys do one on your own, but do you guys have any questions on how to do this? Well, it's not too bad. Okay. All right, last problem for the semester. Okay. This is the last problem I'm going to do with you guys for the semester. I'm not lecturing after today. It's all project after this.
Okay.
I know. Thank God. I don't need to talk to you guys anymore. All right. So this is the structure for cocaine. So I want you guys to take a look at cocaine, and I want you guys to figure out what the formula for cocaine is. Okay, how many carbons there are. So take a second, try that out, and then we'll go over it together, and we'll be all done. Alrighty, guys. Well, congratulations on finishing all of the content for semester 1.